Hey guys, welcome to our first workshop of the quarter. Today we're going to be covering Git.
Couple quick announcements before we get started. January 30th will be our Global Game Jam at DigiPen Institute of Technology. We will be going there in person for a club-wide game with everyone, hopefully. If you wanted to go individually and make your own game for Global Game Jam, that's a-okay. Right after that, February 4th, we will have the Winter Club Fair at the ARC Event Center. We will be having a table. We will be displaying the game from Global Game Jam along with other games that we've made in the past. Come on by and say hi, and maybe we'll recruit some new people. February 6th will be the industry panel, where we have some lovely game developers from across the community coming in, sharing their experience, having a good time. And we're still hashing out the specific details about it, but in the second half of the quarter, we will have our 3D Godot workshop if you guys were interested in learning how to make a 3D game.
Yep, so this is the agenda for our workshop. First of all, everyone should create a GitHub account, like get that done right away. And then number two, we're going to also install GitHub Desktop and or Git. Git is the command line interface for using version control with GitHub. And GitHub Desktop is also Windows only, unfortunately. Number three, intro to version control. So yeah, we're going to talk about the GitHub Desktop, the GUI, and then we're going to get into hands-on work with a repository. And then after that, we'll talk about more things you can do with the command line with Git. So yeah, start downloading Git and GitHub. Git, the command line is optional, but if you want to dig into that, we can also do that. Yeah. Does everyone have a GitHub account set up already? We're all good on that? Cool. And we either have GitHub Desktop set up or the command line. We're all good?
Doesn't necessarily have to be GitHub Desktop. I know it's Windows exclusive. We'll get into it a little bit, but there are more graphical user interfaces than just GitHub Desktop. Mm-hmm. And the concepts that we're going to teach are pretty applicable everywhere. Speaking of.
Yeah, so a bit of a difference between the command line interface. It looks like your terminal, and you mainly work with commands. And then the graphical user interface, it offers like a beginner-friendly like graphical interface that you can use just like any other app. And then there are some examples of GUIs like GitHub Desktop, which is what we'll be using, and also Visual Studio Code can be used to manage your version control.
I'm not sure if you can read the small print too well, but it's not just exclusive to these two. There are other standalone programs for Git, and other major code editors beyond VS Code will also have their own interfaces built in.
Yeah. So now we're going to get into version control and how it works. So first of all, a repository. A repository is used to store and track project files. You can think of it as like a file system on a device or a computer, and it contains all your files. And local repositories are local to your device, your computer, and then remote repositories are what's on the cloud. In this case, it's GitHub. And the one thing to note is that remote repositories is usually called the origin. And then there are also many websites that offer hosting. So we have GitHub, there's also GitLab. There are lots of version control cloud services that you can use. All right, so some more differences between local and remote. Local repositories are usually clones from the remote repository. So files, histories, and all the tracking information for version control is copied straight from the remote repository onto your computer. And every user keeps their own local repository on their system, and any changes you make on your system are tracked only by your local repository. So diffs, with version control, you can see the changes you've made to your file system, to all your files in your local repository since the last commit. And a commit is a named group of changes. So on the right here, you can see GitHub Desktop. it shows like red lines and green lines. That shows lines that have been removed and lines that have been added. So, and there's a third type of line that shows like a line that's been changed. I'm pretty sure that's.
It's like hit or miss on whether or not you see it, but
Yeah.
that does exist.
Yeah, that's diffs. A commit changes must be staged. It's added to like a staging area. That's when you work with GitHub Desktop, you don't really deal with a staging area per se. But when you work with the command line, you use like a command called git add to add files to a staging area. And once changes are staged, they are then added to a commit. And with a commit, you add like additional information such as a commit message, and then a bunch of other information like a hash, timestamp, and like the author of that commit is also added. And all commits are stored in a linear history. Yeah, as you can see on the bottom, each commit builds on the last one. So B builds on A, C builds on B, and so on. And on the left here, you can see the commit history in GitHub Desktop. And then on the right, this is GitHub on
website.
The website, yeah. So pulling and pushing commits, you pull remote commits, so any commits on the remote repository into your local repository, hence pull, and then you push local commits into the remote repository. Yeah, it's pretty self-explanatory. Branches. So branches are basically independent versions or timelines of a repository. So branches allow for parallel development. So if you have multiple people working in a repository, you can each keep a branch that stores your own commits and your own work. All repositories have a main branch. That's usually your release branch. It's your working version of your application. And then branches are usually separated into either features or teams. It depends on how you organize your work with your team. Yeah, so merging. A branch can be merged with another branch. When you do merging, it's usually merging a feature branch into the main branch. And with good management and practices, merges can be clean and easy. So as you can see on the bottom, we have A, B, and then branching off of the B commit, we have E and F. And the main branch and the feature branch have been developed in parallel. So main branch has gotten C and D. And then when we want to merge it, we just add like the commits on the feature branch into the main branch. So we get D, E, F. But merge conflicts can arise from merges, and these are pretty scary sometimes. They often happen when two parallel commits change the same file. So two commits from different branches, they modify like the same file. So in this example, we see E and C. There are two different commits on two different branches, but they modify file.txt. And so we have to resolve these conflicts manually. So merge conflicts require a deep understanding of the files. So you're going to have to understand how the files work and what each line in the text file actually means. And then tools such as VS Code can be used to help visualize and resolve these conflicts.
Usually, it's recommended just avoid these entirely. They suck.
Yeah. One way you can help avoid these merge conflicts is by rebasing. So a branch can be rebased with another branch, changing its history. It's called rebasing because you're changing the base of your branch, the base of your branch's history, basically. Typically, feature branches rebase with the main branch as often as possible. So anytime there's a change in your main branch, you will often want to rebase your current working branch, your feature branch. Merge conflicts can also happen, but if you do rebasing properly and you coordinate your work properly, you can avoid merge commits.
Well, now let's go into some good practices with Git. These are admittedly mostly applicable to teams. If you're going solo, Your Git repository is kind of your oyster. You can do whatever you want. But when you're in a team, would appreciate following these good practices. Number one, people should work in separate areas of your project, ideally separated by your roles and responsibilities. So, for example, your developers should be working with the code folder, your artists should be working in the assets folder. Separating which people are touching what part of the project naturally decreases the risk of merge conflicts. Less people are touching less of the same files. Along the same lines, you should also consider planning out your project and practicing good folder organization. Like physically keeping files separate on the file system will also be a good idea. Lastly, if you have to touch the same area of a project, maybe you have a team of a couple of developers working in the same file, practice good communication so you know when to pull, when to push, making sure no merge conflicts happen. Separate branches. Work should be done in small, separate branches separated by person or feature or task or bug fix. It really doesn't matter. You can make a branch for basically any reason you can think of, but ideally they should be small. You do not want large branches. If you make too many changes in a separate branch, you are basically asking for a merge conflict, and that's going to be hell to resolve. In a team, the main branch should never be pushed to directly. Ideally, you should only merge or rebase into main. And also make it a habit to rebase from main often, just so whenever changes do occur in main, you are always up to date. And if there are any merge conflicts, you will catch them early. When it comes to merging or rebasing, ideally one person should be in charge of merging into the main branch. Ideally, this is a leadership position like the team manager, lead programmer, project manager. These guys should be knowledgeable enough to handle merge conflicts if they show up. You can also use pull requests to manage merging. This is very specific to GitHub. If you're using another hosting provider like GitLab or some other non-Git version control, your mileage may vary. Good luck. One last thing on the topic of merging. Branches should be peer reviewed. It is always nice to have a second pair of eyes to hopefully catch issues before they become problems. Commit early, commit often. Please don't mega commit, which is where you have a single commit that is like tens of thousands of lines worth of changes. You are asking for a lot of trouble. Each commit should be small and focused. Even if they add a lot to the history, they are easier to merge into, and if they cause a merge conflict, you're only looking at one file instead of 10. Ideally, every commit should keep the application in a functional state. Please don't commit stuff that breaks your program. People will hate you for that. On the topic of commits, as we mentioned before, you can have a small little message to your commit to describe your changes. It is very important, especially in teams, to keep these messages short and concise for your teammates. If you have a commit that says fix buggy thing, what buggy thing? What are you on about? What do you mean? But if you're more specific, fixed edge case causing enemy pathfinding to fail, okay. I can understand what your commit's doing now. To give you a bit more of a visual example, here are some historical bad commits that we've made in the past. These are very funny, but they are examples of what not to do.
My favorite one is removed thing.
My personal favorite is Caitlin's. I think there's something alive in the back of my car.
What does that mean?
personal thing, and I got scared. But no, it's all good. My car is
I think my personal favorite that I've made is if main gets a merge conflict, you now know which commit to revert. That was on Filibuster. You're welcome.
Oh, on the right, it's that was one of our games, and our final build kept not working, so we just kept trying to make a final build and thinking it's the final, and just escalates final.
For an example of a mega commit, I also have an example over here. It's kind of difficult to see from the text, but that is 9,700 lines added, 3,500 lines removed. That was for the Stickman project. When I added the gizmo things.
Yeah, but not all of that was code.
Yeah, some of it was Unity stuff, but it's thousands of lines is still a little messy.
Yeah.
Well, with good practices out of the way,
let's get into it.
Let's get into
the actual activity. And once you got that done, we want to go ahead and clone the repository. So on the right, there should be that green button, code. And you can clone it through the command line interface. So there's that link right there that you have to copy into your command line. Or you can open it with a GitHub desktop, and you can search for your repository there. So if you want to show it both ways.
Here, I will. No, I'm already on the second monitor. All right, so here's GitHub desktop. Here it is. I'm going to, I'm going to click the add button. I'm going to click clone repository. If you're using GitHub desktop, ideally you want to get to a screen that looks kind of like this. And then you want to search for Husky Game Dev, the Winter Workshop.
It should show up if you accepted the invite.
Lizzie's good. Everyone else good?
Everyone has it? Great.
All right, we'll be cloning it on desktop. For the command line, if you guys were interested, we're going to copy this link that James pointed out before.
Unless you have SSH key already set up, we're not going to go through that because that's a long process. And if you've already got that set up, then you're good on that.
I'm going to go into my personal projects folder, and I believe the command is git clone, and then you paste a link.
Yep.
So git clone, and you want to paste that link from over here. And then you press enter.
And if you're doing this for the first time, it will prompt you to log in. And I believe it pops up with the web browser with the login, if you have that. There are other login options or authentication options, like I said, SSH. But yeah, everyone has the repository. Sweet. So go ahead and open the project in your file explorer, and you're going to look for the index.html file.
You might be wondering, what are we downloading to our laptops? what are we doing here? Well, we have a little guest book for you guys to fill out to say that you've been here. So we're going to add our names to the Husky Game Dev guest book.
Yeah, but before we do that, we're going to demonstrate pulling from origin. So, Caden, open up the HTML in a text editor.
Notepad.
Yep. And then you're going to add your name to the guest list.
All right, I'm going to add my name.
It's all spaces, by the way.
Yeah, I've noticed.
You could also add my name too.
All right. Did I get your last name right?
Yep.
First try. All right. Save that. Now if I go back to GitHub desktop, look at that, have our names included. I'm going to commit that Wrong monitor.
We need a commit message.
Need a commit message. What would be a good commit message? Would it be hello world?
No,
Would it be add Caden and James to guest book?
probably, yeah. It's a good idea.
Well, let's go ahead and commit that. This is
When your current branch is made.
Well, okay. Did we talk about project maintainers and managers?
No.
Oh, we didn't? Well, okay. Typically, with a GitHub project or any kind of version control project, you have one person that's managing like the team and all the commits and merges, and they're the only ones that push to main, right? And they handle all the merges into main. That's us right now, so we have that privilege. Okay, not you.
Okay.
All right. Well, I'm going to push our names to the guest book. And on your guys' end, you guys should see right here on GitHub Desktop, it should say fetch or ideally pull. You should have one new commit to pull.
And if you open up the command line,
Yeah,
just cd into the.
CD, it would be GD that.
Yeah. So you can do git fetch,
Fetch.
and that's going to download all the changes on the remote repository, but it's not yet merged into your local branch yet. So,
Yep, as we can see, we do have a commit. So we do a git pull. I'm not sure. I don't remember if we need anything else or not.
no.
Yeah.
We clone the repository. We don't have to set upstream or anything. So.
Yeah.
And yeah, so as you can see, get your head out of the way.
Right.
As you can see, it was a fast forward because on the remote repository, it was ahead of our local repository by one commit. So we basically fast forwarded. All right.
All right. Raise your hand if you guys got our names on. If you guys pulled that change.
Yeah, if you open up the HTML or refresh your HTML page, you should see our names.
Actually, yeah. Let me refresh it locally.
Yep.
There you go.
Everyone's good? Sweet. All right, let's go move on to branches. So open up the GitHub desktop and we'll see, I think you can just click, that button, and you can create a new branch. And we're just gonna name the branch your first name.
It can be whatever you want.
Yeah. Usually when you're working with a team, you can do branches like one branch for each individual person, or you can divide it into teams, or you can divide it into like a specific feature. It's really just how you want to organize it.
I'm going to name
It's
my
all
branch
branches.
example just for this workshop, but everyone else should use their first name. And as you can see, our current branch is now our new one.
Yep. And if you want to switch to the command line,
So yes, there we go. I should be able to get
Yeah.
branch, is it?
yeah, just git branch and then name the branch. Example name 2. Yep. And then if you do git branch, just that, it'll list all your branches
Yep.
that you have. Yeah, so right now you have example name 2 and main. Right now main is highlighted as green. That means you're on the main branch. You'll want to switch to your new branch that you made. So you do, it's not checkout. Oh, is it?
Yeah, let's check out.
Oh, there's also git switch. I use git switch. I guess
I
they're the
must
same
be
thing.
I must be a boomer then. If I use checkout.
Yeah, but use either git checkout and then the name of the branch to switch, or git switch. And as you can see, when you type in git branch again, it has the example name branch highlighted. You always want to make sure you're on the right branch, especially in the GitHub desktop. You can also see like your current branch. It's important to keep track of that so you don't make pushes to the wrong branch and mess everything up.
Yeah. Do keep that in mind at all times.
Yep. All right, everyone's got their own branches set up? Sweet. Now, we're gonna push those branches to the remote. So on GitHub Desktop, you have this button called Publish Branch, and that's gonna create that branch on the remote repository. Oops. Yep. And once you open the command line, actually, and then you can do git push. I think it's -u origin and then the name of the branch. So that will set up your local branch to what's a technical word? To track? Is that the right word?
Yeah.
So okay, basically that command creates the remote branch and then sets your branch to track or synchronize with that remote branch.
Basically, a lot of lingo to say that if someone were to push to your branch remotely, your local branch could actually see those changes and pull and push just fine. And now if we go back to the GitHub repository,
We should start seeing everyone's branches show up. So yeah, we have Caitlin's branch, we have Lizzie's branch, and we have our 2 example branches. So if everyone can get their branches published, it'll be epic. I think we're missing.
It's us. We just sign in at this point.
Oh yeah.
first time setup.
It also doesn't show all the branches from that drop. If you click on like all branches, there's
Oh, you're so right.
Oh, I see. It usually shows a lot more branches than that.
Yeah. That's good to know.
All right, so everyone has a branch set up. We're waiting on Wyatt.
But that's everyone?
Sweet. All right, what's next? All right, we're gonna make our first commits to our remote branches. So everyone go ahead and navigate to your HTML file, and then you're gonna open it in a text editor. So don't open it in your web browser. We're gonna wanna edit it. So we have it here in our notepad.
Best code editor, Notepad.
Yep. And then right here where it says part 1, add a new line after this comment with your name in it. You're going to want to do exactly that. Add your name to the guest list. So you just copy the same format, the same HTML format.
Do remember to include the little tags, the P and the /P, just to make sure the formatting is good.
Or you can make it a header if you want to be fancy.
Or you can make it a header if you want your name nice and big.
And then save your HTML file, and then go to your command line interface or GitHub desktop, and you should see your diffs.
I'm probably going to add an example name just to show it live.
No, we're good. We're going to be merging.
All right. Boom. Boom.
Okay, so we don't have any changes made to our file, but the changes you guys made should be visible on the right. The diffs, it should be like a green line or something. In the command line interface, if you want to pull that up, you want to type in git diff, and that will show.
Nothing.
We don't have any diffs right now, but that will show your changes made to the file. All right, so now that we have our changes done, we want to package it in a commit. Actually, yeah, just go ahead and make a change.
Over there. I'm going.
Yeah.
This is the GitHub desktop version. I need to switch it over to the one for the CLI, which is way over here. Whose name should I add in here? Can I add Prahaz?
He's here with us in spirit.
I want to add Prahaz.
Okay. Yeah. So if you go back to your command line and do git diff, you should be able to see that. Yep. Added Prahaz. All right. So now you commit in the GitHub desktop. It's going to be in the bottom left. You write your commit message, and then commit to your branch, right?
Don't forget to add the little summary.
Yep.
It is required on GitHub desktop.
And then if you want to do it on the command line real quick, so
Git
do
add.
do git status first.
Yeah.
So that shows all your changes made since the last commit. And in order to package those changes, you want to do git add. And you can do specific files just by doing git add and then the path to that file. Or you can do git add and then period to add everything. And so if you do git status again after you added, it should show changes to be committed. So that means it's in staging. And if you want to remove it from staging, you just do git restore and then -- staged and then the file.
I'm not going to do that because I don't want to type in the name again.
Yeah, so now you can package it into a commit and give it a message. So you use -m to indicate the next argument is going to be a message. And then prahas my goat. It's a goated message.
No. Don't look, guys. There we go.
All right. So now if you do git status, it should show that you are one commit ahead of the remote branch. So again, that's where origin comes back. The origin is the remote branch. And then you can git push to push your commit to your remote branch. And if you're on GitHub desktop, you can just do, there should be a button and it should say push your
origin.
commits. Yeah, push origin.
It will replace this little fetch button. Instead of fetch, it'll say push, and it will show like an up arrow with the number 1 on it.
Yeah. So now if you go to GitHub, the website, and you navigate to your branch, your remote branch, it should say this branch is one commit ahead of main. And then on the right, you'll see your commits, sorry, the center column. It'll show the commit messages. And then index.html has that commit message that you wrote. That was the latest commit.
Yep, 1 minute ago.
Yep. So everyone should have a commit on the remote repository done. Are we all good? Sweet.
Yep.
All right. Now comes the fun part. Now, what we're going to do as the project managers is we're going to merge all your guys' commits into main. So get to it, Caden.
All right. Do you want me to do it the terminal way or the desktop way?
We'll do like a couple through the GitHub desktop, I think.
All right. I want to fetch everyone because I believe that's how I also get everyone's branches. Yep. I can see everyone's branches here on origin.
And then I think you go branch up top in the menu.
Like new branch?
No, the option, the menu.
Oh, toolbar.
I've never done this before on GitHub desktop. So you can merge into current branch.
Yeah, but it wants me to be on the destination branch
Oh, yeah.
first.
Yeah.
So I'm going to switch to main.
And then we're merging other branches into main.
It. So merge into main. Whose name shall I add first? Who wants to be added first? Isaiah. So merge one commit from Isaiah into main. Yes, please. And
yeah. So it's a simple fast forward since your branch is only one commit ahead of main. So we didn't have to do any fancy commit, merge commits, I should say. So it was nice, easy, and painless. But trouble comes when we start adding everyone else's commits.
Merge. I'm going to go down in alphabetical.
Yeah, so now we have a merge conflict because everyone
no.
edited the same file.
Uh-oh.
So it'll say, yeah, create a merge commit, and it's going to ask you to resolve the merge conflict. I think GitHub Desktop has that functionality.
Yeah, it's asking me to open it up in Notepad++.
Oh, actually, yeah, that's actually preferable. Pull it up.
All right. So welcome to Notepad++.
Zoom in a little bit.
Yeah, I've never had to do it in Notepad++ before. So
So we have these labels here that were created by Git, and we have these left arrows here called head. That's our current branch. That's our main branch right now. And the branch that we want to merge into main is down below here, below these equal signs. And that's basically, this is the merge conflict. And right now, we have to resolve this by either we can remove Isaiah completely, or we can accept a combination of both, or we can accept a combination of neither. We just have to delete the labels and then like make our changes with the lines manually. So this is where the project manager has to be very knowledgeable about the text files and how the files actually work, because you have to go in and manually edit them. So if you're working with like Godot, you have like your senior resource files, right? And they're formatted very specifically with very specific formats. So you need someone that's familiar with that in order to handle merge conflicts properly.
Heaven forbid if you're working in Unity and your scene file gets a merge conflict, God help you. There's no recovering from that. But since this is an HTML file, that was a relatively simple, it wasn't even a conflict really. I just accepted both changes. Yeah. And now GitHub's saying everything's been resolved. I can continue the merge. But now we have 3 commits instead of 2.
Yeah, so what happened there is, if you remember before, the button said create merge commit. What we just did there is basically a whole commit, like making the merge between the 2 commits. That's a whole new commit. And usually that's not a problem, but it can really spiral out of control, and it clogs up your commit history. If you have just, oh, I merged this branch into this branch, I merged this commit. You can have a ton of commits that are just merges, and it gets super messy.
Well, let's give rebasing a shot. Let's rebase main on top of someone else's.
That's not part of the plan.
Damn.
And I think it's going to come up with a merge conflict anyways.
Let's keep going down the list.
This time, can you show VS Code?
VS Code?
With the merge conflict. So
okay.
try merging it. And then we'll do the command line. Yeah?
Okay, I was a little bit behind with how to add something to the file, so I just copied it or git cloned on VS Code, and then I just added my name and then I pushed it, but I guess I wasn't on my own branch, so I pushed it to the main. So sorry guys.
I can
I don't know how to do the branch, I guess. Like I made a branch on GitHub desktop, but I didn't.
Oh, did you not push it to the?
I don't think my VS Code is connected to GitHub desktop. So that was my bad.
Oh yeah, I can see that I need to pull a commit.
Hold up, let me go to the repository. Where's the link? Yeah, main. Yeah, Lizzie pushed. Yeah, add Lizzie to the list.
I can just pull it with a rebase.
Yeah, that's fine. So we're gonna do a rebase real quick.
On desktop or terminal?
Do you guys want to see the rebase in the terminal? All right.
We're going terminal.
So if you do git status.
This is.
Oh, you need to switch to.
Yeah. CD.
Switch to main. No, you're in the right.
No, this is the GitHub desktop version. Now if we go git status, 3 behind, 1 front.
Yeah. So the 3, we're 3 ahead. We made 3 commits, right? That was we merged the 2 branches and made the commit merge commit. And then we're behind by 1. So that's you're 3 and 1. And on the remote branch, Lizzie pushed a commit. It's all right. But now we have to somehow resolve this. And one way we can do this, we can resolve this, is by rebasing. So if you do git rebase origin main, I think.
Slash main?
I think it's origin / main, yeah. Yep. Yeah, so sometimes when you're rebasing, you still get merge conflicts, but that's fine.
That's fine.
Yeah. So Lizzie added her name here, and we're just gonna do a combination. When you're managing merge conflicts, you have to remove those labels.
Yeah, you have to, or else will complain.
Sometimes it doesn't complain. Sometimes you can accidentally force finish the merge, and those labels stay in the file and basically corrupt the file.
I should mention, I got a little bit ahead of myself. I resolved the conflict in Notepad, but on the terminal, I need to git add it again and then execute git rebase dash continue.
Yeah. So that git add just means we're telling git that we resolved it. And make sure you make changes to the conflicts before you do git add, or else it will corrupt your files.
Second conflict, oh boy.
Oh, do we have to do conflict resolution for every merge?
Well, we've added everyone's names to the website. Our
Okay.
guest book is looking nice and populated.
All right, and now everyone switch to your own branch on your local machine. So you do that on Git desktop, and then we're gonna do.
Wait, I'm having like issue like pulling fork main.
We have changes on the main branch that we want to get into our own branch, right? So what we can do is a rebase. So go to, in GitHub Desktop, you can do, from the branch menu, rebase current branch, and make sure that you're on your own branch, not on main or anything. And then we're going to select rebasing with main. So what this will do is it's gonna change the history of our current branch, and all the changes that we made to main, it's gonna basically be applied to our branch. And rebasing kind of does, make sure you want to rebase. Yeah, rebase will require a force push, like we talked about earlier, because it's changing history. You have to force push to your remote branch when you rebase. All right, and then once you have that done, you can do a push origin, and that will force push your changes to your remote branch. All right, and if you want to show it in the command line,
I might have to go back to my remote. I have to go back to this guy, but thankfully I can. Nice thing about Windows 11 is I can open a new terminal here. All right, so now where's my second terminal? Here we are. There we go.
all right. Now let's do a git status real quick. Make sure we're on the right branch. On branch example name 2, good. And now we want to do git fetch main, just to make sure we have main's changes fetched. Or is it, or it's origin slash main?
Yeah,
sorry.
Origin slash main.
Right, origin main.
Thank you, Git.
There we go. So now it says we've downloaded the remote main branch, and now we can rebase. So we do git rebase, and we're just not origin. Well, we could do origin, but since we already have the new changes, oh, we'd have to merge it into our main, right?
Yeah, I think we have to pull it locally because fetch is not a pull.
Right. Okay, we could do git rebase origin main.
Origin slash main or origin space main?
I don't know. We gotta
Fine.
try it.
Oh, okay.
Oh, there we go. So yeah, so that's one way you do a git fetch. Well, technically, actually, since we do git rebase origin main, we don't have to git fetch it. You could just go straight to, because you're specifying origin, and that will just read the remote repository.
Well,
But yeah.
anyway, so we're up to date.
Yeah. So if you do git status, we'll say that we are
Why does it say we're on
we're on
branch main?
branch main. What'd you do?
Why is it on?
Wait,
it?
what?
Why did it?
Oh, does git fetch change your branch?
It would be very funny if it did. But I mean, I guess worst case, I just updated the main branch here. I didn't do anything destructive.
Okay, yeah.
Just switched me to main also.
Yeah. I guess git fetch does.
Oh, I did the wrong command.
I did
here.
not know that.
Get switch and then get rebase origin.
Okay, so nothing should have changed. If you
Still
if you
switched to
rebase
main?
with main on your local branch, it shouldn't have. Yeah, you do git switch.
Yeah, I get switched, but when I rebased again, it swapped me back to main.
Okay, well,
Oh well.
did you do huh. Well, another way that we probably should have done is you switch to your main branch and then you git pull, and then on your local machine, your local main branch should be up to date with the remote main branch, and then you would rebase with your local main.
Get rebase just main.
Yeah.
Buh.
That's it. Well, there's a part 2.
Well, the part 2 was about making a git merge conflict happen, but we
Yeah.
just had it accidentally happen.
If you guys want to handle a git merge conflict yourself, we do have a part 2 for that, if anyone's curious. But I mean, that's pretty much the gist of git and version control. Yeah.
We do actually have a part 2 of the presentation about advanced topics.
Oh yeah,
over time.
let's get to that. Nobody's interested? Nobody wants to do a merge conflict?
I think we've demonstrated plenty.
Yeah. We can finish up here.
Good work, everyone. You can open up that that HTML file in your web browser, and all of our names are on it.
Yeah. So the part 2 was the favorite number. We were gonna everyone put in their own favorite number and then do a merge conflicts, but it's fine. We're gonna move on. All right. So here's some additional Git. This is more specifically command line stuff, but some of these concepts you can also do in GitHub Desktop.
Some of these features we're about to show will also be on elsewhere, like VS Code. I have a screenshot from VS Code with one of these advanced things.
Mm-hmm. So git ignore. This isn't actually like a CLI or a GUI feature. This is a file that's inside your repository files, and it's basically just telling Git which files to ignore when like uploading to GitHub, or well, which files to ignore when tracking files, I should say.
It's generally recommended to use this if you have like an output folder for your build and you don't want to like constantly commit your builds to the repository.
Or like in Unity, you have your library folder that's gigantic. You don't want to push that. So usually when you make a repository, you have options to pick a git ignore, or you can download a git ignore template online.
Yeah, generally anything that isn't strictly necessary for the project itself should be included in Git ignore. This also keeps the repository small. The repositories do actually have a size to them, and if you were to try to clone a project with thousands and thousands of commits, that takes time.
You want to talk about this?
So git blame. Git blame is a special little thing that goes through your files line by line and tells you who the last person touched your file. But it is most often yourself. So if you want to try to figure out who exactly written a line of code, you can use blame, but of course I know him, he's me. Tags. So tags, they can help people connect a specific commit to a version release. GitHub, the website, requires you to tag a release every time you make a new one. For example, this was the 3D Stickman repository.
Mm.
It has two tags, so 1.1.0 and 1.0.0, and each of these tags is tied to a commit. So if someone was like, I need to visit the project at a specific version, they can click that tag and it brings them to that specific commit that I made the build with. It's very useful for keeping track of release versions, and it's pretty handy.
Stashes. So what we did earlier, I think it was, who did the stash?
I think it was Kaiser we did the
Yeah,
stash.
Kaiser did the stash. Basically, stashes allow you to like save and restore work without a full commit. So any changes that you made, when you want to like switch a branch or something, but you don't want to commit your changes immediately, you can do git stash. And there's also functionality in GitHub, stash all changes. You can do that in GitHub Desktop. And when you have changes in your stash, if you want to restore them, you have to pop them. So you use stashes to restore the uncommitted work. In the command line, it's git stash pop.
Stashes are incredibly useful if someone is bugging you for a last-minute bug fix, but you're in the middle of a deep refactor. They can be pretty handy. Even more commands. Do you want to rapid fire this one?
Yeah, so git status, we covered this. You want to use this as often as possible. Like pretty much after every git command you do, you want to do git status. Just make sure you're on the correct branch. Make sure you're doing what you think you're doing, because if you're working out of context, you can make some huge mistakes that just destroy your repository. Git log, this shows your commit history. Git cherry pick, this allows you to pick a specific commit from another branch, and you can basically merge it into your own branch. Git checkout checks out a specific commit in a detached head. We kind of talked about this before. Git restore restores changes in the local repository, so any changes that you made since the last commit, you can restore that. You can also restore staged changes. And then git reset, we also talked about this. This resets the branch to a specific commit. One thing we didn't cover was git reset using head. So head basically points to your latest commit on your branch. And if you do like head ~1, that goes back one commit. So you can reset back one commit on your local repository. And you can also do git reset soft. So this is useful. I use this all the time to amends commits and squash commits. Basically what this does is this takes your commit and then resets it, right, to the commit before that. But all the changes made in that commit, they're added to your staging area. So they're not deleted permanently like in hard. Yeah, that's about it.
I think that's the workshop.
Cool.
Cool.